2 times, or 3 times 2 is 9.
3.
3, so like 3 doubles.
Okay, which would be 3 squared. Okay. Okay, you see an equal sign, all that? Okay. All right, so you see 3 squared equals 9. What else do you see? So you're seeing that this number, square, or to the root of that, gives you that. Okay, anyone else seeing that? Okay.
They're all blue.
They are all blue. They are all blue. They all do have an equal sign. They all have the word log. Very good. In addition to that, we are seeing that if she's seeing that 3 squared equals 9, 10 squared equals 100, 5 cubed equals 125. Does everyone see that pattern? Okay. That is a good thing to see. This is actually, what we're going to be working with today is a pattern. What we have here are logarithms, and we'll be actually talking about this pattern in just a minute. So that's great that you guys see that. So just seeing the pattern right there is going to make our next step really easy, okay? So let's just kind of talk about a few definitions here, okay? Pretty much, we have been dealing up to this point. 10-1 was we dealt with exponents. You guys remember exponents, right? So when we were dealing with exponents, exponential, I can't spell today, functions. Okay, that we wrote as y equals ab to the x. Okay, so when you see the word exponential functions, this is what we've been dealing with, right? Okay, well, what we're dealing with today is what's called logarithm functions, and it's actually what we call the inverse or opposite of an exponential function. So just like subtraction is the inverse of addition, division is the inverse of multiplication, right? Logarithms is the inverse of exponential functions. So you can go from one to the other, okay? So just like you can go with addition and subtraction, you can do the same thing with logarithms, okay? So they're related in the fact that they're inverses of each other. Okay, so a logarithm and exponential functions are inverses of each other, or they're opposites, okay? Okay, and because of that, there's a pattern, and we'll be working with that pattern. Okay, so again, the inverse of an exponential function, which I'm just going to put y equals ab to the x, okay, so you can remind yourself that that's what it is called a logarithm. Okay. And the answer, so the answer that we're trying to find now to a log is going to be an exponent. Okay, so we're trying to find the value of the exponent. You see that okay? Okay. So basically we have a couple components to a logarithm, okay? So it's kind of hard to see here. I'm just going to rewrite it to make it bigger. Log, and it has this little b down here. It has an x there, and it equals y, okay? So this is kind of like the format, just like how we have y equals ab to the x. We have this log bx equals y. And in this, okay, the b is what we call the base, so just like we did before. Okay, the y is the exponent, and then the x is the value of the base raised to the exponent. And we'll look at all those in just a sec. Okay, so if you look at these examples that we saw here, okay, so on this one, the base, let's say we look at this one, the base would equal 5, the exponent, which is y, would equal 3, and then the value of the base raised to that exponent is going to equal x, okay? So I could rewrite this then as 5 to the third equals 125. Okay, because that's the base, the exponent, and that's the answer. Does that make sense? Okay. All right, so now, a couple of restrictions. We do have some restrictions on what each value can be. X always has to be greater than 0. Okay. B always has to be greater than 0. And B cannot be 1. So there's just some restrictions, and we'll look at how those work in just a little bit. Okay? And how we say this, so basically when we start talking about it, we kind of say, you know, something is the base or whatever. How we actually state it is we say log, so we want to read it as log base, and then whatever your B value is, of the X value is Y. And we'll give you an example in just a sec. So if I was going to read, let's say, this one, okay, I'm going to say log base 5 of, now our X value is at there, so log base 5 of 125 is 3. Okay? And this is the is part, because this is your answer. And remember how your answer will be an exponent. Okay? So that's why we're solving for the exponent now. So is always going to be the exponent answer. Okay? So log base B of X is Y. So if I would state this one here, we have a couple examples. This would be log base 2 of 8 is 3. Right? So this would be log base 2 of 8 is 3. What would this one be? Log base 1/3 of 9 is -2. Okay? So this would be log base X of Y is Z. Make sense? Okay. So what's going to happen is they're going to give you, this is what we call a logarithm function right here. So this is our logarithm function. Let's do log function. Okay, that's how you write it. And now it wants you to write it in what's called the exponential function right here. It wants you to convert it. So we want to go from this, where we have it like this, to where we have it like that. Okay? So our exponential function is going to be where we actually state it as the base. So you'll have the base y equals x. So the exponential function is by equals x. So we're going to take it from where it says log 2 of a equals 3, and we're going to say we want to be by equals x. So how I would write that as is the 2 just swings underneath the 3 here, and it becomes 2 to the 3rd equals 8. It is. Okay, so we take the base, and remember how the base is always the base with an exponent. So this is always my base. It's just going to swing underneath that number on the what it equals, and then it's going to equal whatever the answer is, which is 8. So what would this one be? The 1/3 swings underneath the -2, so it becomes 1/3 to the -2, and that equals 9. And does that make sense? So 1/3 to the -2, to make it positive, what do I do with the fraction? If I have a negative exponent, what do I do to make it positive? I have to flip it and then change it to a positive, right? So a 1/3 to the -2, that actually becomes 3 squared. That equals 9. Does 3 squared equal 9? Sure does. Okay? And does 2 to the 3rd equal 8? Sure does. Alright, so this one here is going to be x to the z, and that's going to equal y. Make that a z. Okay? So going from a log, this is a logarithm function, to an exponential function. Okay? What you're doing is you're going to do the log b of x equals y, and that's going to get converted to b of y equals x. Okay, that's converting it from log to exponential. Does that make sense? Okay. Good. Okay. Just like you can go from 1, then you can work your way backwards. Okay, so I can now go from an exponential to a log. Okay? So with that said, okay, well, so I have 36 equals 6 squared. So if we're going to go from, and this is an exponential here, this is the exponential here, and I want to go to log, which is the log b x equals y, right? I'm going to go into that, right? But remember, this is b of y equals x here. So I just have to switch it, right? So how do I get from here to there? Well, just how I threw the 6 up, what do I need to do with the 6? I just got to pull the 6 back, and then I have to add the word log. Okay? So I'm just do log, I pull the 6 down, it is 36, and that equals 2. So just like I swing up, to do the opposite, I just swing down. It's like that little graphic.
So we have to do it both ways.
You have to know how to go both ways, right?
Do we have to put log over there?
You have to put log there, otherwise you're completely not doing what you need to do.
Alright.
Okay. So this one, so what do? I swing it down, right? So I'm just going to swing it down, and I add the word log. So I'll do log 2/3 8/27 equals 3. Does that make sense? I don't know if it makes sense, but do you get the pattern? That might be the better question. Okay? Alright, so the same thing here. So I'm going to swing the 3 down. I'm going to add the word log. Log base 3, 1 equals 0. And that's right, right? So 3 to 0 equals 1. Got the pattern? So going from log to exponential, okay, you're going to swing the 2 up, get rid of the word log, and they equal each other. And then going from exponential to log, you just swing it down, write the word log, and that's going from one to the other. Questions? Okay. All right. Hello. It gives us the answer in the fact that when I do this, it tells me 2/3 equals 8, so I have what 2/3 equals, okay? On this one here, I have 36 equals 6 squared, and that converts to log base 6 of 36 equals 2. So I'm not actually finding anything on the equal side, I'm just converting. That's all I'm doing right here. This is all conversion. So example 1 is conversion, okay? Example 2 is conversion. You're just swapping, going backwards and forward, okay? The difference between example 3 is there's no equal sign, and so what we're actually finding at this is this word called evaluate, and when you see evaluate, then you're trying to find what's on the other side. You're trying to find that equal, okay? So evaluate means find what it equals. So at this point, this is going to go back to what we did the very first in 10.1, where we had to find the same base. Remember how we had to work with bases, right? So at this point, if I want to evaluate, I would write this as like log of 5, base 5 of 125 equals, and we don't know, okay? We don't know. It equals y. So we're going to add this equal y part. That's the evaluate. Okay, that's what it means. Find the equal y part. Okay? So if I would rewrite this, this would be rewritten as, again, bring the 5 up, you're going to have 5y equals 125. And so now you're trying to solve for that exponent, aren't you? Okay? And this goes back to 10.1 where we said, well, how do we actually find exponents? What do we need to do? If we can have the same base, then we can just put the exponents equal to each other and we can solve, right? So we're just going to do that. So what base should I use? I have a 5 and I have a 125. So if I pull out my little chart, if you guys don't see it, what would be a base? What would be a base? Can 5 be a 3? When you have something like this and you're trying to solve for an exponent, you can't solve for an exponent like this. So what we do is we convert to the same base. So when you have a number with the exponent as the variable, you want to find a common base. Okay? So I'm going to start with my smallest number and just see if I can find the other number on the same line. So I go to 5. And I go all the way across, and I see 125. So 5 can be a base for 5 and for 125, right? So at this point, 5 can remain as is, because 5 to the 1 power is just 5. 125 then can be written as 5 to the 3rd power, right? Because I have 125 underneath the x cubed, so I can rewrite 5 cubed, okay? So I'm going to say 5y equals 5 cubed. Right? So everyone see how I did that? So now, because they're the same base, I can drop them, and then I can just put the exponents equal to each other, and it's going to be y equals 3. Okay? So when you get it where you don't know the exponent, you want to find the same base, and then you put the exponents to each other and solve for the exponent. Okay? Alright, so let's try B. So in looking at this one, again, when you don't have an equals something over here, that's what you want to put, equals y. When it says evaluate, you want to put equals y. This is what this means. Okay? So now, when I have it like that, I convert it to be an exponential function. Okay? So then once you have it like this, convert to exponential function, which means it's going to be 2 to the y equals 1/8. Okay, does everyone see how I went from there to there? Okay, so I did 2, put it underneath the y, so that's 2 to the y equals 1/8. At this point, I need to solve for y. Well, I can't solve for y because I don't have the same base, so I need to make 1/8 the same base. Okay, so if I look on my 2 line, I go over and I see 8, so 2 cubed would give me an 8, right? So I could rewrite 1/8 as, so it's 2y equals 2 to the negative 3. Okay? Because this is actually going to be 1 over 2/3, right, to the third, and that becomes 2 to the negative 3. Right? So now the bases drop, and then I could rewrite y equals negative 3. Just put the exponents equal to each other, and that's my answer. Okay? So then that's my answer. So y to the negative 3 is going to log of base 2 of 1/8 equals negative 3. Okay? Because it's 1 over 2/3. Yeah. You need to flip it. You need to have the base the same, because 1 over 2 is not the same base as 2. So to make it a 2, a base of 2, I flip it and then change the sign of the exponent. Okay? Alright, let's look at this one. Log base 27 of 3 equals, we don't know, so let's go ahead and work that. It's going to be, so we're going to have 27y equals 3. Okay, so 27y equals 3. So, how do I make 27y equals 3? Well, what base do I need to change it to? So I look to my smallest number of 3, I look on that line and see if I see 27. And I see I have x3, right? But, so I have 27 can be rewritten as 3 cubed, correct? And that's times y, you don't want to lose that y, and that's going to equal 3. And what is 3 when you have no exponent? What's the implied exponent? 1. So I'd probably put that there. Okay? So the 27 gets rewritten as 3 cubed, and then you have that y that comes down, so don't lose that y, right? So anything that is being raised to still gets multiplied.
So you have 3/3 becomes like 3 to the 3rd power.
Yeah, so 27 is 3 to the 3rd.
Oh.
And then I bring my y down because the 27 is being raised to that. So then this can be rewritten as 3 to the 3y, and that's going to equal 3 to the 1 power. Okay? So what can I do with my bases?
Cross out the 3, right?
Yep, cross them out. And so I have 3y equals 1. So how do I get it to be just y? Divide by 3. So y equals 1/3. And that would be correct. Okay? So 27 to the 1/3 would give me 3.
Happy birthday!
Oh, no, we have to say.
Quiz, there's a calculator portion of it, and then your test, there's a calculator and non-calculator. This is the non-calculator part, okay? So you have to understand how to do this, okay? So, very quickly in going through this, this is going to equal, you have to, when it says evaluate, you set it equal to something. Evaluate means find an answer, okay? So I'm looking for 4 to the y equals 32. Well, I have to have the same base. There is no 4 and 32 on the same line, so I have to go smaller. And so I go smaller, I have a 4 and a 32 on the same line, so my base is going to be 2, okay? So remember, you guys, this is your base. This will be your base number when you look, okay? So I have a base of the 2 for my 4, so this becomes 2 squared times y, and that's going to equal 32, which is a base of 5, so 2 to the 5. So my base is crossed out, and I have 2y equals 5, so y equals 5 halves. Okay? On this one here, this is going to again equal y, so I have 64 to the y equals 1 over 32. Then you don't have 64 actually on this side over here, you guys, but it's actually right there. It would be 64, and that's going to be x to the 6. Okay? So I can rewrite 64 and 32 with a base of 2. So I will say this becomes 2 base 6 y, and that's going to equal 1 over 2 to the 5th. Well, I need to have the 2 in the numerator to make it the same base, so I have to, the rule of exponents, if you flip it, then you change the sign. So this becomes 2, 6y equals 2 to the negative 5th. So drop your bases, 6y equals negative 5, y equals negative 5, 6. Okay? Questions on that? Good? Because it's 1 over 2 to the 5th, and I have to flip it, and when you flip it, you... Yeah, because you want it to... This is 2 over 1. That's not the same thing as 1 over 2. Okay? All right, questions on that? All right, so... Good and bad for you guys. We can't get through everything today, so we're just going to flip and do one more thing, and then I'll let you guys look at your homework real quick. 44.
Is it the properties of logs?
Yeah.
Dang. Well, then we're actually going to get into graphing these ones?
Yes. Not today, though.
We're going to get into that just yet.
All right, you guys, we will not, on a positive note to you all, we will not get to graphing today. Okay? So we're going to stop here with the properties. Okay? So there's a few properties that when you use them and you see them, you can default to a particular answer. So they may look really complicated, but when you know these properties, you can easily pull out the answer. Okay? So an example is as follows. You may have where it says like log to a base of something that's raised to an exponent, and that equals an exponent, okay? So if I do log, I'm just going to rewrite this, b, and it's to b of x, if I would rewrite this as an exponent, it becomes b to the x equals b to the x, doesn't it? Right? Because if I just pull the b underneath there, it becomes b to the x, and that equals whatever's right there. So that is actually... that equals each other. So if you get a situation like this, your answer just becomes whatever this evaluation over here, then just becomes whatever that exponent is right there. So when you have it where the base and your evaluation is the same, then just that exponent becomes your answer. Okay? So in this one here, this actually becomes 8 to the y equals 8 to the 5th, right? So my answer just becomes 5, because that makes it the same. So when you see the same base to the evaluation right here, these just kind of cross out, and then this becomes your answer. Okay? Make sense? Okay. Here's another property. When I have what's called a b, so this is like b log base x equals x, okay? Your answer then just becomes, hold on a sec here. Your answer, if you notice here, these match, like this matches right here. Okay, see how they match? What's your guess of what the answer equals? Well, here it tells you it equals whatever your x value is. Well, what's my x value? It's the exponent. So on this one here, when the base to the log base match, then your answer just becomes the exponent. So this just evaluates to 8. Okay, so when you have the same base and log base, then your answer is just the exponent. Okay? On this one, when you have, for any base, this is for any base, it doesn't matter what it is, if it evaluates to 1, anything to what power equals 1? No, 0. Anything to the 0 power gives you an answer of 1, right? So this is like saying b to the what gives me 1. Well, anything raised to the 0 power gives me 1. So if I have log base and it evaluates to 1, the answer will always be 0. Because this is 6 to the whatever equals 1. Well, anything raised to the 0 power gives you 1. Okay?
I'm confused on the second one.
Okay. 0, 1, 0 power.
Does this say any base?
This is any base. So it can be any number. So basically what this is saying, if I have a base and it's raised to the log of the same base, so let's say this is, I kind of rewrote it, so it's like 3, and then it's actually, you see log 3, and then it has a value here, 8. Because the bases are the same, they cancel out, because remember the same bases cancel out, so then the answer is just 8. Okay? So in an example here, you're given two properties and you have to kind of identify the answer. So if I say simplify, this one here we have log 7, 7 to the 4th. Well, this is going to use property number 1. Okay? This is going to use property number 1. And so therefore, how does this evaluate to? Log base 7 of 7 to the 4th evaluates to what? Evaluates to 4, because that's the answer right there, right? So log 7, base 7 of 7 to the 4th is going to evaluate to what? It's going to evaluate to 4, because it really is saying 7 to the what equals 7 to the 4, right? So when you see where the base and the evaluation are the same, it's just going to be the exponent's going to be your answer. So when you see this, you can simplify it by just saying what the answer is. Okay? So what does the next one? It's a base to the same base, so these kind of cancel, so this evaluates to 3. So it's going to be 4 plus 3 equals 7, yeah. So you just take what this is, find what it evaluates to, and then do the math inside and have that equal whatever it equals. Does that make sense? Okay? So do the evaluation and then do the math. Good? Questions? Alright, so just very briefly, you guys, and then I'll give you guys, you'll have about 10 minutes to start your homework. So we talked about logs being the opposite of exponents. Okay? We have log b to the x equals y. B is the base, y is the exponent, x is the value that it raised to. We showed you how to go from a logarithm to an exponential function. Again, throwing it underneath equals 8, or throwing it underneath and it equals your evaluation. We've gone the opposite way where it's the exponent, you throw the number back down, add a log. Okay? When you don't have an equal sign, it says evaluate, you throw the equal y there, and then you want to get the same base and solve for your exponents. Okay? And then you have your three properties, and when you see those three properties, they're going to want you to simplify by finding what they evaluate to, and then doing the math that it's in between. Good?
All of it.
Okay. So with that said,